You guys caught me on a bit of a tea break. So in this video, we're going to be looking at a proof. We're going to be looking at the proof as to why the radius will always intersect a tangent at a 90-degree angle. Now, this proof is written up very nice and neatly and beautifully, not like how I'm scribbling the videos. So if you want to get access to all my nice neat notes, make sure you're on my website. What we're going to try to prove today is that, well, we're not going to try, we're going to prove, is that the radius and the tangent make a 90-degree angle at the point of intersection, right? So the point of intersection is where the tangent touches the circle. So if you don't know what a tangent is in a line that will touch the circle exactly one and only one point. What we're going to prove today is that if you're standing at the center of the circle and you were to be walking directly along the radius, that would lead you to the point of intersection between the tangent and the circle, that you could put a 90-degree angle there. Now, it's important to remember that perpendicular distance, that means if the line that you're walking along and the line that you're going to meet at 90 degrees, that's what perpendicular means. We've talked about that in the equation of the line. The perpendicular distance is always the shortest distance. It's always the smallest distance. So we've got our diagram going here. So I've drawn a circle. This is its center. Now, P is going to be where the tangent touches the circle. So that's the point P, the point of intersection. Now we're going to assume that P isn't where the right angle is, and we're going to imagine it's at point Q. Point Q could be anywhere else on the line. Now, if that's true, then the distance from C to Q needs to be the shortest possible distance from the center to the line, right? The smallest distance that you could go if you're walking at the center of a circle. Imagine this was train tracks and you were going to walk towards the train tracks or to the road or something. Now, we know that the distance from the center to the point of intersection with the tangent is radius. That has to be radius because look, this line goes from the center to the outside, right? Because point of intersection means it's on both the circle and the line. So we know that this distance here, and I've got it in red. I usually put radius in red for that reason. That's the distance of R. So imagine that there's another point on the line that's a shorter distance, okay? So we call that point Q. Now that means if I'm walking from the center, the fastest way to get to this line needs to be to go to point Q. However, that can't be true because in order to get to point Q, I have to go to the edge of the circle. That's a radius. And then I have to go this little extra bit here. You see this little extra bit here that's in purple to get to point Q. So it has to be true that C to Q is always going to be longer than C to P. So that must mean that if I can do that for any point on the circle, right? Like imagine I take a different point Q. I say, okay, maybe it's over here. Well, this is still going to be longer because this is going to be a radius and this is going to be like a little bit extra, so it's going to be longer. So the shortest distance from the center to the tangent needs to go directly to point P, which means the shortest distance is going to be R. Now, if that's the shortest distance, and that needs to be where the right angle is. So that must mean that a radius and a tangent will intersect at a right angle. And that gives rise to a lot of questions about Pythagoras' theorem, perpendicular lines, all of that good stuff. In summary, shortest distance means that's where the right angle is, and the shortest distance has to be P, and the shortest distance possible would be traveling a distance of R. Any other distance would be R plus a little extra bit. So we can put our right angle in here. I'm going to show you how you can take this theoretical proof and apply this to practical questions in the next key skill.